So the ORAN Alliance started actually in 2018. It was a merge of the C-RAN Alliance and the X-RAN concepts. You can see the founding members, AT&T, China Mobile, Docomo, Orange, and Deutsche Telekom were all the founding members of it in 2018. And the goals, their vision, was that we would have an open RAN, okay, a smart RAN. It would be decoupled from the hardware, so it's virtualized, use cloud-native technologies, and that it would become interoperable. And that interoperability is a key component to a lot of the aspects of openness. That means you have standardized interfaces, they are open interfaces, and it opens the door for the ultimate goals. So really these two on the bottom, interoperable and virtualized, are building blocks for the two concepts on the top, that it's open, anybody can join, and that it's a smart network. Sort of gone are the days of the monolithic stack. We want, and if we look towards 6G, we see a lot more intelligence being incorporated in. Okay, since its foundation, you can see it's a rather large community. There's over 300 members involved in this ecosystem. They come from operators around the world, vendors around the world, and academic. This is a new area where we're bringing in academia into the innovation cycle for the actual telecoms aspects. And that has to do with the intelligence. It steps a little farther than that because of the open source aspect of it, and we'll talk a little bit about that later. Okay, so here's what does it do? Specifications. They are an SDO, a standards defining organization, and that goes to the interoperability. We define the interfaces between the components of the RAN and what they do, what their expected role is in the network. Testing is key and integral to the part of it. And I think on our panel we have a lot of the OTICs represented. These are the places where these things get tested. Are they compliant? And there's a badging process that allows them to be certified. You sort of see the badges down here. It's sort of talked about at the bottom of the slide with certified, interoperable, end-to-end tested. Those are badges that they can earn at these OTICs. And then we have this ORAN software community. And that one is a unique aspect to this because it's not about the standards themselves, it's about the functionality. And what does that really mean? So the other are how you do it, okay, or what needs to be done, and the other one is really more of an approach, not necessarily the only approach, but an approach as to how to get it done. So the composition ORAN, they have these things called focus groups. They report to the TSC. Then you have working groups, and those are the things that drive the specs. In the middle is the overall ORAN architecture. You can see some of the alignment in there, right? Slide. I took this from an ORAN slide and pasted it into the O&E format, and I guess some of the colors didn't work out so well. And then you have these ad hoc committees, the Next Gen Research Group, which is looking forward towards 6G. There's a Minimal Viable Plan Committee, and they try to work out end-to-end features that operators need. Okay, and they therefore try to work a plan to focus, create a thread that goes through these working groups, and make sure that we got all the specifications in all the different areas that would enable a feature that the operators want to have. And then the last one, it says Ad Hoc Committee for Procedures is no longer ad hoc. It is the ORAN Committee for Procedures. So it went from ACOP to OCOP. Big change there. But basically it's how do we operate, the rules and stuff like that, so we all do it in a consistent manner. Consistency is really key when you're doing standards. Even if we're doing it the wrong way, it's best if we all do it the wrong way, therefore it becomes the right way. And we have, as an organization, we have some alignment issues. Our SDO doesn't really, it borrows from 3GPP for some of the RAN stuff. It borrows from ETSI for some of the cloud stuff. if we're going to publish our specs, even for the RAN, inside of Europe, it needs to go through an ETSI process. And we're looking at what the impacts of ATIS in North America are and what that might have for us to actually also publish there. So it's a complicated world out there when you're a SDO, and so we do it. Another interesting aspect, though, of ORAN as an SDO has been the confidentiality. Originally, it was very confidential. Everything was sort of, you had to be a member to know anything. That's changed, okay? Due to some issues with membership and with exportation laws and stuff like that. They've adopted a new agreement of terms that if it's technical in nature, it is by definition then non-confidential. And there, as long as you know an ORAN member, you can probably get access to it, even if it's pre-spec, even if it's work in progress. It's all open and transparent if you know somebody to ask. So you don't have access to the websites if you're not a member, but if you know a member, you can ask for data from it and they can freely give it, as long as it comes from the non-confidential side of the data tree in the wikis. So this is the contributors in testing. So like I said, we said there's conformance, interoperability, end-to-end. We support, I think we're still at 2 plug fests a year that we sponsor. Then there's the OTICs, and we are constantly looking at qualifications for OTICs to come in. And the ultimate goal is these badges. When somebody has these badges, it means they've been tested by an independent party to be compliant, and that gives operators a certain level of assurance that they meet a certain level of specification. Now, some of that hasn't been fully defined, and there's debates going on in different work groups. What is actual compliance? What is not compliance? What's testable? What's not testable? And that discussions are part of the thing, but the tests are just another specification. And so we follow the same guidelines we write for the specs to develop the software. We follow the same guidelines for the specifications to test the software. Okay. 2 special groups that I'm going to focus on a little bit here is the open source focus group and the ORAN software community. If you look on here on the left, the OSFG, the open source focus group, they're sort of chartered with the goal to find solutions in open source for ORAN problems. And that is not just within the OSE. OSE is just one piece of that puzzle. So they have a very broad view. They look at all the community as a whole, holistically. They look at the things like the wireless blueprint, the super wireless blueprint, and how effective that strategy is. How do we enhance that and stuff? Where should the focus be in these industries, and how can they influence it? So they're more of a target specifier. They say, here, these are the things that are important that should be get done. And then the source communities, the different groups are working towards that. They also give us alignment. The first direction they gave us was alignment between OSE and OAI. Okay, and that's been a very beneficial relationship over the past year. We've done a joint workshop and stuff where we saw a deepening of the relationship between it. And I think that's going to continue to deepen. We've even talked of going deeper than it is right now in terms of potentially consolidating, like near real-time RIC as an example, where there's a large overlap, but they're not a point for point. So some things are developed stronger in OAI, some are stronger in OSC. The best of both worlds would be a blend. So it's something that's on the table. We've talked about it. They haven't really done a lot to how to reconcile it, so there's not too much true activity in doing it. But in the TSC and among the TSC leaders, we the OSC Technical Oversight Committee, we do talk about it and its possibility. So you can see here the co-chairs are from China Mobile's Jinri Irfan from Eurocom, and Tracy Van Brakel from AT&T. On the right side, you have the OSC community. And it's a partnership with the LF community. So the LF Foundation is the enabler for it. ORAN becomes the sponsor. I co-chair the OSC with Jin Rhee for the Technical Oversight Committee of the Open ORAN software community. Inside of that, we have several projects that are going on. And if you look on the left side of this, the orange stuff is us that we've been working on. The SCCL and stuff like that, we want to be able to take code as specifications. So we want to be able to we're in the process like in ORAN, that when they publish a spec, they will also publish the code fragment that represents that. So we've been doing some of it for data models, Yang files. So you publish the Yang files with the model, and that's good. But we haven't yet really taken the bigger step, which is like open API specifications or other artifacts that we would specify. And there's some talk in the different work groups of how they would need to or to enable that. But it would be these things that you can use as code that would be put into this copyrighted license, because copyright exists. And this has been our challenge, is that 3GPP and other SDOs, they maintain copyright. So we can't republish their stuff, but we're open source. So if we include in our source code a copy or the reference of their specification, we had to copy it in to do the build, and then we publish that, we've republished their copyrighted material and violated copyright. And we've been handcuffed by this for a long time. SCCL is the doorway to solve that problem. The other side, these are other Linux Foundation projects. Some of them are very interesting that talk ONAP. And if you talk about the OAM aspect with Alex when he gets there, you can give him questions. We leverage ONAP heavily. We also are currently opening, there's others besides ONAP that we leverage. In our OCloud, we leverage other open source things for the operating system of the OCloud. We're integrating with Nefio. That's a project. You'll hear from that later today too. We have an excellent lineup today. Talk about all these different things. So this is really what the OSFG deals with, okay? So it deals with these open source related issues for the Alliance. So they talk to the Technical Steering Committee. They have the planning and the preparation. They're working on a white paper on how to, I think it's to do CI, CD, and testing, CT, as a solution set across multiple communities, right? It's not just, this isn't just OSC. This is how do we create a complete environment of a cellular network. That means you've got the core, you've got the transport, you've got the RAN, and you've got the cloud that enables those things. So all of those aspects are part of that scope, and so it's a tall order. And then here you see here at this one summit, they're trying to get a better blueprint. The 5G super blueprint has sort of gone stale, and we think that there's a better plan with this, especially with the CI/CD/CT model, where we can prop it up and those different projects or things can feed to a common instance that could be run as an exemplar. And therefore, then you would be able to replicate. So if you're wanting to build your own private RAN and you didn't want to go out and spend all the money to see if it's worth it first, hey, pull it up from open source and then harden it where you need it. So that's a very interesting thing. As I mentioned, the co-chairs already. Okay, I'll talk a little bit about what is OSC. So this is a collaboration between the ORAN Alliance and Linux Foundation for the creation of the radio access network. It does not deal with the core, it does not deal with transport, but it does deal with the cloud, because part of that, the ORAN space is the cloud. And the reason it's interested in the cloud is because in order for us to standardize the management system for the RAN, it also has to have a standardized interface to the cloud on which it's deployed. So the unique thing about an O cloud, the ORAN term for a cloud, is that it has an O2 interface, okay? And so other than that, it's pretty much a cloud. There's some other nuances to it and stuff like that. Be happy for anybody who wants to talk about it, reach out. We can talk about the O cloud. It's a discussion that's ongoing even within ORAN about what is exactly an O cloud. How is it testable is the real question though. So our OSC projects, okay, we have 13 projects. We are doing our 10th release now, so 9 releases so far have completed. You can see that there's a broad spectrum of projects here. It covers everything from infrastructure, the cloud, okay, integration, end-to-end testing or automated testing of interfaces, pairwise testing. Then we have several of them that make up what we call what they call the SMO. One of them is the SMO, but it's not an SMO unless it includes a non-RT RIC. Okay, we want AI/ML enablement for anything that's running in the SMO, and so that's an integral piece of it. And then there's some basic OAM functions, and those are things like being able to actually connect to the network, get data from the network, and those aspects. And so we leverage a lot of ONAP stuff. Like I say, Alex will have a discussion on some of that a little later. The elements, there is the OCU. However, the OCU project was sort of suspended, and it's been inactive for years now. We just couldn't maintain the support level for an open source version of it. However, in OAI, which we have integrated with, there is an open OAI version of the CU. And so we use that. We also leverage, Radisys has a version they license to us to use as a comparative. We want interoperability, so it's always good to have at least something to compare against. And so we have 2 different versions of the CU that way. And then you have ODU high and ODU low. Okay, and this is the separation. And why would you separate the 2? Because in much of the models that we have, there's a notion that especially as you move to higher frequency radios, is that the low aspect, the low management, the PHY level of the interface, you need the hardware acceleration to keep up with the activity. Because as your frequency goes up, your time window goes down. And so the faster responses are needed. So when we're doing just a general one, we actually do ODU low as a binary. We can deploy it on a cloud node, same as our ODU high, and it'll act as a separate one. They'll still interface exactly the same way. But later down the road, if we wanted to integrate with an accelerator card that had implemented ODU low, there would be virtually no change to the ODU high. Other than there would be some change. I shouldn't say there wouldn't be any. It is not considered interoperable between those 2. It's not a defined, standardized interface. We leverage FAPI. We've been leaning on FAPI and trying to push FAPI more and more to help us, but we don't drive the FAPI spec. Okay. I'm just going to sort of breeze through these. You can feel free to read these. These are sort of the projects by sort of category. And I can just read them by name. But so support projects, we have the documentation project, we have the simulation. Alex is the PTL for that. And then we have the integration testing, and that's James, and he's here as well. In the O Cloud, Jackie is the infrastructure. That's the O Cloud infrastructure. ODU High, Ankit does that, and Peng from Intel is our ODU Low. If you're interested in any of these areas, the website is open to the public. You can actually go out there and ping these PTLs and see how to get more involved. On the near real-time intelligent controller, we sort of group the RIC and the RIC apps. The RIC apps has been largely focused on the X app. We have 2 terms for these applications. The applications are intended that separate from the SMO, separate from the near real-time RIC provider, third parties can develop apps These are the intelligent pieces of the puzzle. This is where all the intelligence is. The rest are frameworks, okay, that enable that intelligence. And that's where then you get X apps onto the near real-time RIP and R apps onto the non-RT RIC. Within the SMO, we have the SMO project, the OAM project, non-RT RIC, and the AI/ML. And those all sort of cleave together. There's a construct inside of it's being developed in ORAN in the working group 1 that has the architecture. It's called decomposition. Originally the SMO was just this blob, and the only thing that you could see within that blob was that there was this non-RT RIC that had these capabilities that made network management unique to the intelligent RAN with an intelligent controller for the RAN. And so that was the distinction. Well, just like we did this disaggregation of the RAN itself, they decided that why stop there, okay? The SMO is so large, so big, that we should break it apart. And I think Shankar is in the room here, and he's one of the originators of the whole concept for that concept of disaggregating the SMO. So the SMO decomposition work, we basically have 3 building blocks. We can decide which services we put into which, and when you put them all together, you have an SMO. Okay, where does all our integration happen? So we supposedly have 3 labs, and I'll get to the supposed part. Okay, the most reliable one. I'll start with the most reliable. We'll work our way backwards. Most reliable one has been the NTUST out at Taiwan University in Taipei. They have a complete replica of what was supposed to be in the Bedminster, our North America East Coast lab, and complete with OCloud and with ODU high, ODU low, an ORU simulator. So they have pretty much everything in there. They are connected to other universities, other labs, so that it can actually bring up a whole network. So it's by far right now the more advanced and most reliable lab. BMU is here from that lab. If you have questions, you want to talk to him, look him up. He's in the room. BMO. I'm sorry about that. I talk to him every week, so it's not like I guess being on stage affects my voice. We have a West Coast lab that's right here in Cupertino. It's really geared towards testing the near real-time RIC and the RIC apps, comparison testing, evaluating them, running them through their paces, making sure they work. They sometimes use Powder, and I think we have some people from the Powder labs that help augment the resources that they use for that testing. So when we're talking about the lab session and the panel talk, if you have questions on that, feel free. And then there's the East Coast lab. Now, it was in Bedminster, and it was a full-up lab, had everything, okay? And then the AT&T and its consolidation. You know, we found that after COVID, we didn't need all the real estate that we had. We had some real expensive real estate, so we decided to move. It's like only about 3 or 4 miles down the road. When they shut down our servers for the lab and got to the new lab and went to power things up, they were short 2 things, okay? Circuit breakers, for supply chain couldn't supply the ones we needed, so no power, and chillers. We couldn't cool everything that we did have up and running. And so as a result, they were the lowest priority. Everything else is AT&T mainstream. This was not. And so they've been there ever since, turned off. Okay? We worked out with Accord, the government aspect, and we've decided that it's very much in alignment with what their needs are and what ORAN's needs are. There's a little difference in some of the users and the tools a little bit in the tool use. But for the most part, it's a very strong overlap. So between ORAN and Accord, they can supply a lab at Rutgers. And so we're going to move our Bedminster lab to actually where the OTIC is, where Cosmos is, and we're going to put it as a sandbox in that same place. And that will allow us. Now, the OSC labs are not OTICs. So let's not be confused about that. They're not a testing place for certification and badging. These are places where we integrate. This is where we would run, where we would do the CI/CD/CT process in order to do it. So that means we got to have a place where we can develop and a place where we can deploy, both. And one is up and running all the time. The other one is a hit and miss as you develop and things get to a point where it's releasable. Then you commit it to the release and off it goes through the process and things start to get updated. So very much a developer's environment as opposed to a completed product I want to test and certify it type of environment. So what does ORAN get from the OSC? This is a fundamental question. What do they get? I'm going to go through some case studies that talks about how do we interact as an OSC. Got two hats. One is OSC, one is ORAN. Okay. What does ORAN get from the OSC? Okay. Why and be involved in the first place? So just with our first 3 releases, so when we started Amber, we started the Amber release the exact same time as they started the first draft of the concepts of the A1 interface. There was no A1 prior to this. There's no A1 policy. Okay. And they started writing that policy with some assumptions. Okay, they thought it would be more like a service model, like the E2 interface is done that way. All the policies would be up front and defined. The problem with that assumption is that the R apps and the X apps are the things that define what policies are allowed and how they would be used. These are going to be done by third parties. We don't know what their contents are yet because they're coming from after we've defined the specifications. Then there'll be people that come up with the next best R app or X app. And so you don't know what they are ahead of time. And so that problem became occurrent because they thought the policies types would be dictated by the service model. And therefore, everybody would know about those types and their structures prior to development instead of discovered as you deployed. So when we first got it, we made it work, but we couldn't implement it to their specification. As a result, we gave them that feedback when they came to their release 2, which was around the time we got to Cherry. And we said, hey, we've been trying for a year. We went through our Amber and our Bronze release, and we could not make that work in open source. We just could not do their specification as it was written. It wouldn't work. And we gave that feedback to him. He says, but if you change it like this, we can implement it because we have this working. And they had actually adopted that very model. So with the release 2 of the A1P policy, the actual code that we'd already written became in alignment because they updated the spec to how it could be implemented. And that's a direct going to implement. If you're able to implement a spec, because a lot of these specs are written on theories, on conjecture, on ivory tower, on standards groups that have never written a line of code. So having somebody actually coding it and trying to make it work and giving that feedback that it's doable is really key to the success of ORAN. After Cherry, we started with just alphabet letters. Somebody mentioned that our color names that we were supposed to use were awful following some other model that was not as favorable, so we went back just to the letters of the alphabet. So D through F, this is a demonstrative period that we went through where we wanted to be able to check, is an interface that we had a connection to healthy or not? And so, and with it was a very minor loop on the ORU losing its link to the ODU and how could we recover from that. And so there's a model of the closed loop that we demonstrated. And so this was, again, it's not following the standards precisely because we don't have all the interfaces. We don't have all the R1 interfaces for the R apps. We don't have some of the other interfaces at the time. We couldn't do it per 3GPP, but we made some assumptions on what we think it's going to evolve to that we could take advantage of. We couldn't publish with 3GPP specifications because of copyright issues. So we created our own. Alex can tell you about that too. So basically, we were able to mimic this environment. And like the interface health check is that there is an RAP that was developed that says, I support the hello policy, okay? And the hello policy is simply one that you can create and then you can destroy. And you can check on its status while it's created. And so that's the XApp says, I support it. The SMO says, hey, do you support this policy? It says yes, okay. Create a policy instance. We check and see, is it being enforced? You do that by checking its status. It comes back, yes, great. Let me destroy it. Make sure it goes away. Ask, hey, can I create this? And you get the error back. So it was really testing to make sure that that flow worked for A1 policy on the A1. And we've used that on occasion because we had different A1 servers. We had one from the near real-time RIC. We had one from ONAP. We had one from a test stub in non-RT RIC. So it was always sometimes a question says, well, which A1 are we running? The health check helps us make sure that they all are sort of like the same. F through G, we did another reference implementation of a closed loop. There was also training, thanks, that the AI/ML workflow is that the project was introduced. We worked out how does it work and interact with the non-RT RIC, creating some of the training workflows. Okay, H&I is has been more focused on the OCU to ODU, ODU low RSIM, and these last two is talking about interoperability with the OAI and Nefio. Nefio being the latest, it's an enabler, we think, for the SMO. Specifically, we need ones for what's called the NFO and the FOCOM functionality of the SMO, and we think they're enablers for that. We'll find out more as they come up with their use case. Seshu is the SMO PTL. He's here today, and he also works with the guys over on Nefio, and they're going to come up here and talk about Nefio in the SMO. J&K, these are we've been updating the CI/CD and the blueprint and trying to get the labs interconnected. It's still a work in progress. And where do we go next? This is sort of the heart and soul. 6G isn't divine. Everybody believes that it's more intelligence in more parts of the network, though. I don't hear anybody disputing that. I got a reference. If you ask what 6G will be from ChatGPT, you can see a list here. Okay, and take it as, I don't know how much of it's hallucination and how much it will be real, but this is what ChatGPT will tell you that 6G will look like. But the real thing is that this is only limited by our imaginations, really. We can decide what intelligence goes in and where it goes, and we can actually develop that. And so that's sort of where we're at. The ORAN's goal is to be virtualized, so that's being cloud native and with a standardized O2 interface using, and cloud native means use a lot of the CNCF tooling. Standards based and broken apart into little parts that can all be put together. Therefore, the building block went from a big thing in the types of the G node B into a lot of little parts. So companies that are good at certain aspects of the RAN can play in the game now. And that's the key to the open architecture. Anybody can play. Doesn't matter who you are, okay? If you're academia or vendors or operators, you can join ORAN and you can participate that way. If you're not any of those, you can join OSC and still play in the game, okay? And learn whichever aspect you're interested in. We've got a lot of moving parts, whether it's in management systems or if it's in the RAN itself. And of course, the SMART is only limited. I put this note in here that the sky is not the limit because a lot of companies are now exploring the low Earth orbit satellites for providing cellular coverage on the ground. And so that's a big play. The sky is not the limit. Space is out there. The key to this thing, though, is that, we're at a tipping point. If you saw how we walked through these case studies and we build up to the 6G world, I look like it that the age, maturity of software is, like dog years, except for dog years is an oversimplified model. Because the engineers, we've got to complicate everything. So I believe it's a little like 4 times the Fibonacci number of years, that equivalent of the years that you do. That would put us right at 5. That means like we're 20 years old. We're ready to be mature. We're ready to figure out where we're going in the world. And so as we are growing up and we're doing that and moving out into mainstream, now's the time. This will be, if you look back 10 years from now, this room, you're in this room, you're in the place that's going to define the next 10 years of the future. You're going to get us to 2030. You're going to get us to 6G. This is it. This is how we get there, is with this. Thanks.